Okay, questions? Okay. So we've been doing MVC, and we've done a lot of it, and we'll do a little bit more of it. Okay. So you guys can see this properly? The lights are a little brighter than normal, but anybody have problems seeing this? Sorry? It's fine? Good, good, good. I can see you guys better now. Let's go back to BMI spreadsheet, and let's look at this get BMI function, which seems like a very 101-like function to write. And let's try to analyze it a little bit. So get BMI uses this formula. And the question is, can this formula go wrong? Can something bad happen when this formula is computed? Okay. And this picture here shows you what could go wrong. Okay. So what happens if I put height and weight as 0? What do you think is going to happen? Some kind of division by 0 error, right? And if you divide 0 by 0, you get something that is not a number, okay? And you get BMI to be this NAN value, and the user might look at it and know what you meant or have no idea, okay? And so something went wrong. And we are going to do the blame game here now, okay? We're going to try to figure out who did something wrong. That's the whole job here. Not how to fix it so much as who to make responsible for this thing, okay? So the idea is that maybe we've got a very big program with lots of methods, lots of classes too, and we just want to make sure that if something goes wrong, we can identify where it went wrong, okay, and who was responsible for making it wrong, okay? So that's the goal, and we've got a very simple function here. We'll try to analyze this. So is it get BMI's fault that this bad thing happened? No. Okay, it's not get BMI's fault. Whose fault is it? The user, asked Austin? The programmer, but there's lots of programmers, right? There's somebody who wrote set height, somebody who wrote set weight, and there was, of course, the end user also. So the end user at some point might have entered 0, and the error should be given.
So when the user enters 0 for height, it shouldn't have been allowed to set 0.
So maybe it was set height's problem.
Yeah.
Okay, and set weight's problem. Mm-hmm. Get BMI says, look, assuming those values are correct, I'll go and fix this. And it is set height and set weight that should be catching the error early rather than later when get BMI is computed. So BMI is not at fault now that we've analyzed this, okay? But when we were writing BMI spreadsheet, we didn't think about all these issues. We just wrote the thing, and we wrote all 3 functions. So now that we understand this, we said, well, get BMI should really not have been asked to compute with 0 height and weight, okay? And I wrote get BMI, and so I should, and you wrote set height and set weight. Somehow we had to communicate with each other to figure out who's going to do the checking when, okay? So, we could put a nice comment and get BMI saying that, look, height and weight should be, I thought I fixed this. It should be greater than 0, actually, not greater than equal to 0. They should be greater than 0, okay? And so that's good. If you read my comments, you'll figure out that it was you and you wrote set height, you can figure out that it was you who should have got this error, okay? But let's say you don't, you skip over comments, okay? That's one problem that occurs with comments, okay? So I always encourage you to, do something that is more than comments that can result in executable code. And you might have skipped over comments, or maybe you just made a mistake. So when the error occurred, when we say NaN, we would like to be informed at runtime where the error was, what went wrong. Maybe not what the error was, but what went wrong. The comment that should have been read should at least now be read. Okay. So how can I go and give this message I'm giving to my co-programmers when this program was written? Okay. I'd like to give this message to whoever is interested at runtime when something bad really happens. So what could I do in getBMI? I could go and print out a message.
Can't you do a try and catch or something like that?
We could do a try-catch, but 2 reasons we won't do that. Firstly, we don't know what try-catches are right now quite, okay, and we might never actually quite get into exceptions. But this is not quite a try-catch thing. Okay, an exception is something that solves a different problem. Okay, and we'll get to see exactly what the problem is here. But like I said, with try-catch, you're catching things at runtime, errors that can occur in runtime. This is error shouldn't have really, I mean, there's something that could have been prevented by programming properly. So it's not a question of some unanticipated thing happening that you couldn't program against. Okay? So how to locate the problem at execution time, and I could give a message. And to give a message, I can go and have a little if statement. Okay, we all know how to write ifs, and we're going to write an if saying, look, if weight is less than or equal to 0, height is less than or equal to 0, something went wrong, print out this message. Okay, nothing difficult here. But there's a couple of issues here. One is, so when they did go to 0, when they did go to less than 0, either of them, what value should I return? Yes, I printed out a message, but my getBMI function has to return something, so it's still going to return this funny value, and all kinds of other issues are going to happen. So maybe I want something more than an if. Okay, something that doesn't have to return a value. Okay, that's one issue. The second issue is that if everybody is careful, if weight never became less than 0, if height never became less than 0, if everybody was good, we're paying the cost of this if statement being executed each time. Okay? So you're penalizing the good people by making their programs slow. Okay? And what you want to do is catch this error once, and then, if there is going to be an error, and then never have to go and check the if again later, as long as the error is not manifested again. Okay, so you want something where the people who weren't programming properly could pay the price of having this if executed, and then they have the benefit of seeing what went wrong. But the people who programmed well shouldn't have to go and suffer the inefficiency of this if being executed each time. Okay, so we want to have a cake and eat it too, and we can't quite use an if, because an if will always be executed, and an if will always and we have to figure out if doesn't tell us what value should be returned by the method. So we want to overcome these two problems, that the code is always executed and value must still be returned. Okay, so if doesn't do it for us, we need something from Java that's going to overcome these two problems. And that something from Java is called, and we want in conditional compilation. So we want not only do we not want the if to be executed at runtime, we don't even want the if to be compiled. Okay, and at compile time. So we want something that's conditionally compiled and doesn't require us to return a value. What an assertion is. Okay. An assertion says, so you can see the assert has two parts. There's a colon here. The left of a colon in general would be a Boolean expression, right? Very good. And the right hand, on the right would be a In this case, it's a string, and you would say it's probably an error message of some kind. Okay, that's what we see here. And it says, and if I was to translate this into English, what am I saying? When program is at this point, I assert that this condition is or should be true. Okay, that's what I'm saying. I'm making an assertion. This is what I expect, and if everything is going right, this is what will happen. And if I'm lying, if something bad happened, don't return a value. Okay, which could mean just terminate. That's what it really means. There's ways to not terminate, and there's a debate as to whether program should terminate or not. And the purists say it should terminate, and the non-purists say, nah, we could do something about it. So that, there's Java is somewhat schizophrenic about what it wants there. But let's just assume for this class, it will terminate. Okay, and when it terminate, so we've got assert Boolean condition, and it's not a string, it's an object. And that is meant for people who want to not terminate and do something with the program. Okay, and what it does is it announces an assertion error, and then the error is printed out on the console of the program. It terminates, and it basically takes the toString value of that object and prints it out if the condition is not true. Okay, so that's what an assert is. It's pretty much an if, except that the if can cause the program to make this assertion error and not terminate. And terminate, okay? So no return value needed. That's one property of assert. The other property is that the program assert may not even be executed. That's what we wanted, right? If the program was in a certain mode, it won't even be executed. So there is a notion of assertion checking being on or off. Okay? And by default, checking is off. So if you go and put this assert statement and say assert false, which will always be false, nothing will happen to your program. Java just ignores it because the assertion checking is off. Okay? And we want things to be, at runtime, we want the assertions to be either on or off. And we might be debugging certain classes and certain packages. Okay? So I might have assert all over in Object Editor. And when you run Object Editor, you don't want all my assertions to be causing problems because you don't even know how to interpret them. Okay? So you can go and say, this class or this package I want assertions for, and for others I don't want. Okay? So in Java, not at compile time, that's something you could want, and in some languages you can do that. But in Java at runtime, you can go and pass to the Java interpreter certain arguments to indicate what assertions should be on, to indicate which code assertions should be on for and which code assertions should be off for. Okay? And minus EA would mean, if you want to, what would EA expand to? Enable assertions. And DA, disable assertions. So I'm saying enable assertions for all code that is in, and disable it for all code in this, not class, but package. Okay? So you can follow an enable assertion or disable an assertion by a class name or a package name. Okay? That's assertions. Pretty much I've told you everything about assertions. How to use them is another story, but that's really what an assertion is. Okay? And just to show you how assertion actually specified, if you go to in Eclipse, if you go to the arguments tab, you have the arguments that the program takes that are passed to main in args. Those are the program arguments. And then these are arguments that are provided not to your main class, but to the VM, but to the Java interpreter. And that's where you would go and enable or disable assertions. James?
On the previous slide, you had Java, you might put Java minus
EA.
EA assignment, not class. It didn't it end in a semicolon? Does that line of code require it in a semicolon, or did you just leave it all?
Okay, when I do enable and disable assertions, there's no semicolon there.
Okay.
It's only when I assert.
So the line where you say, I want to enable assertion in this class, that does not mean a semicolon.
No, because semicolon is separating two parts.
Okay.
And in there, minus EA, this class name, then space, minus DA. So the space was your delimiter. Okay? And minus EA just says enable all assertions. Okay? Now, in your assignments, I'm not going to ask you to enable assertions. We'll see that we can make you write assertions without actually you having to enable them. And in any case, if we want to enable them, when we run your programs, we can enable them. So you really don't have to, you can, to test your program out. But when you submit your program, it doesn't matter whether you've enabled or not disabled, because we are the ones who have to do that. Okay? So we can't check. So assertions are basically stating some expected property of the program before either the statement. So assert is a statement, right? Before that was a statement, after that is a statement. So you're either indicating that this condition is holding true after I execute the previous statement, or I'm saying this condition is true before I execute the next condition in the statement. Okay, so I'm trying to say, here is what I'm saying some property should be true. That's what assert is. Okay? And before get BMI is called, height and weight should be greater than 0. Okay, that's what my assertion is. And do you see something like things like this in real life when we go and assert some things? Something like this. So when you enter this class, what is something that you all had to assert essentially? That you knew these properties. You knew these subjects, okay? So we'll see something called preconditions, and preconditions are a lot like prerequisites. Okay? So this is something this is just an analogy I'll use a little bit later. And actually, asserting certain properties is something we do all the time in programming. Even before we saw this assert, we've been doing this. Okay? So I'm going to put this in quote because these are not Java assertions. But when I go and say, I have a variable called s, and it's of type string, what am I asserting to Java? I'm saying I will assign to s only values of type string. And if I lie to you, Java, please give me an error. Okay? So that's what you're asserting. You're saying, look, this is what I want to happen. I don't know if I'll make that happen or not, so please check this for me. That's another way of saying it. Okay? I don't know if I told you guys about the override annotation, but you can put an override annotation before a method. And you guys might have seen this. If a method has an override annotation before it, what does that really mean?
Well, it's inheriting, don't use the super, use this version.
So, you're always very good with interpreting these things. So it's saying use this method rather than the super. But the fact is that when you define a method in a subclass, that is going to be used. Even when you didn't put the override annotation, it was going to be used. So what might override be saying? It's saying, so the calls will result in that. It's saying that something is true. That this is what I believe I'm doing. I am writing a method that overrides my superclass method. If such a method doesn't exist in the superclass, please tell me something is wrong. So I believe a method with this signature exists in the superclass, and if it doesn't exist, please let me know. Actually, in Java, the name is really bad. It also means I'm defining a method in an interface. I'm implementing a method in an interface. So that method better be either in a superclass or in an interface. And if it isn't, Java will tell you, sorry, you're mistaken. Okay? So when I go and cast some value, again, I'm saying, this is what I believe is going to happen at this point. I believe at this point, no matter how I declare next element, it's going to be a string. Okay? So that's an assertion I'm making. It's not Java assert, but it is some property I'm indicating, and Java will catch us if that property is false. Either at compile time or at runtime, it will catch us. Okay? So this is something that we do all the time. And with assert, we are asserting properties at runtime rather than properties at compile time. Okay, that's one thing. And we are asserting, when I when I do a cast, that is also a runtime property. But that runtime property is a property that Java knows about. It's got a little if there, condition there, but that condition, it was hardwired into Java. Now what I want to do is assert things that are not hardwired into Java. That means I have to give expressions. And that means I should be able to write these expressions. So when we want to do application-dependent properties at runtime, go to asserts. Okay? So language can only provide us with a fixed number of application-independent assertions. Okay? It's something very general. It can say, this should be a string, but the first character is a letter. That seems very application-specific. That is something you should be writing yourself and not having Java have a predefined assertion for that. Okay? So that is why, in fact, the letter concept is not even burnt into the language. And you can have innumerable assertions about letters. Second element of string is a letter, third element of string is a letter. So we can't have predefined assertions. So we have to have some language to express arbitrary assertions. And that is what we get with assertions. Okay? Now, as it turns out, Java originally had no assertions. Okay? Right after Java was invented, I was at a conference where James Gosling, the inventor, gave the keynote talk. And after the talk, he was asked, what is the biggest mistake you made in Java? And he said, I didn't put assertions in. Okay? So that was Java, I don't know which version. I guess it was 1.0. And by the time 1.4 came along, he had added assertions. Okay? So assertions are important. And assertions, in fact, take two forms. I gave you the long form, where after the Boolean expression, you can give give an object. But if you don't give an object, you just get a generic message saying assertion failed. Okay? And when your commercial applications have failed, have you ever guys seen a message saying assertion failed? Some programs do that. Okay, assertion number 5 failed, they'll sometimes say. Okay? So that's better than a blue screen, but it's not very indicative. It's not meant for the end user. It's meant for the fellow programmer. Okay? So if condition is false, Java throws assertion error, and depending on which assert is used, prints either the generic message or value to string. Okay? And by default, it's terminated. So no value needs to be returned by the method in which the assertion fails. That's important. Okay. So like I said, that's all we need to know about the assert statement. Okay, but now the question is how are we going to use it? And before I taught this course, the people who taught this course spend the whole course more or less on assertions. So this is how much time you can spend on assertions. Okay, and I went to Java, went to object-oriented, so there was a lot of other things to teach also. But of course, I kept assertions. And at the end of at the end of the course, I asked people, what are the concepts you really, really want to remember after the course? Okay, and then I also said, what are the concepts that you want to purge from your brain right after the final exam? And number 1 on the list was assertions. Okay, so I guess I didn't motivate them well enough. Okay, and what I did then was change object editor so that it would make use of assertions. And then when I did that, people were using assertions when I didn't even want them to, need them to. So people were excited about it. I'm going to tell you one particular application of assertions that you can use with object editor. But otherwise, this is not quite the course to do this. There's a course that Jack Snoyak teaches, I forget its number, which spends a lot of time on assertions. And so you get more practice with it. But assert is something that you really, really should know. Even programming, when I teach 101 or 110, I teach assertions there too. It's not a hard, if you know if, you can do assert. Okay? It's a very important concept. Okay? So how to use it is the issue. And right now I said, look, assert is something you execute. That's a property that occurs before the preceding statement, after the preceding statement or before the succeeding statement. Okay? But you might want to associate properties not with individual statements, but with blocks of code. Okay? So a method, or all methods in a class. You want to give some general property saying that's some condition. And can you guys, a precondition of a block of code would be? A condition that, so a precondition of a block of code. Yeah, Zach?
A condition that must be satisfied before the block is finished.
Before the block is executed. And a post condition would be? Assuming the precondition was true. So you're saying, here's a block of code. Okay? My precondition is this. If the precondition is to this, I will execute correctly, and I will make sure that the post condition is true. So precondition is what I demand from people who call me. Post condition is what I give after I've executed. Okay? And that's how that's a very nice way of writing blocks of code. So state some expected property of the program before or after some block of code. And what would an invariant of a block of code be? Some condition that is part of both the precondition and the postcondition. So you say, if this is true before, it will continue to be true afterwards. So if I'm a set height method, I say, whatever the weight was before set height will also be the weight after set height. I guarantee you, I'm not messing with weight. Okay? So that's precondition, post, and invariant. And, okay. Now, I have now made this a precondition, and look what I'm doing. I'm saying I'm asserting now something, a method that proceeds with the prefix pre, okay, which indicates precondition. And notice that I made this method, so the method returns a value, Boolean. It's got an expression. So I put the precondition in a method, and I made this public, okay? And we'll see why we did that later. But basically, what I've done this is define the precondition of the getBMI method, and I could have easily written a postcondition also. And like I said earlier, precondition is like a prerequisite, and invariant of a piece of code is a precondition that is also a postcondition. So I might say that, look, if you guys enter this course with a certain GPA, I'm not such a conservative grader that I'll lower your GPA as long as you work hard. Okay? So I might say, look, your GPA will be at least that much after this course as long as you do all the assignments and get average on exams. Okay? I might go and say something like that. So I'm not saying it. I might say it. Okay? So the invariant could be something like that in the course example. Okay? And whatever you learned before this class, you'll still remember afterwards. It's not as if it's not working that nicely, this example. But you can imagine something like this. Okay. Now, I had a comment here. And I don't have any comment here. Is that okay? So in the top piece of code, I don't have a comment. In the bottom piece, I do. Zach, it's okay? I've got that information, no? You're looking at this, you're seeing this as a precondition. If you know that there's a convention for precondition of methods being pre followed by the method name, you can just look at getBMI and look at the pre method before that and look at this precondition. I don't have to say anything, it's all encoded. Not only that, maybe some grading tool or object editor could even discover the preconditions because I made it public. Okay? So assertions are a form of documentation. They're just not comments, but they're a form of documentation. Okay, so When I told you that before this class, people did a lot of preconditions, this class was called the class for documentation. And there was a lot of emphasis on comments, of course, but there was even more emphasis on these preconditions and postconditions. It doesn't matter whether your program works correctly or not. You're just informing some reader, look, this is what is expected. Okay? This is some property that holds true. Okay? So assertion uses are potentially for documentation. And I just told you some other usage just a few minutes ago, but what other uses could there be? Testing. I kind of hinted at that. That if, we can go and check. We could run your program with assertions on and see whether the assertions thrown or not. We could even see whether you define certain preconditions, postconditions. Anything else? Debugging. Okay, so testing is after you've assured me that things have worked right, I test you out. Debugging is when you're not sure yourself, and you go and look at assertions. What about before the program is even written? Specification. I can go and
When I get to this part of the code, I may not know how I get there, but when I get there, I want this variable of this thing.
okay, so that's so when I go in, I'm telling other people that look, this is what I expect to happen. Okay, and if this happens, I will give you this postcondition. So if somebody wants to prove the program correct, either by testing or by looking at the program, there's a whole field of computer science that does program verification. And you can prove programs correct by saying, this is the precondition of this piece of code, and this is the postcondition, and this piece of code calls this piece of code. I can say that when the program begins, if this is true, when the program ends, this is what's true. I can compose these preconditions, these conditions together. So program verification. And also, it could be specification. When I go and give you a method in an interface, and I go and give you a bunch of methods in an interface, and I say, please implement these methods, what does that mean? It means basically you have an implementation with that method signature, right? That's not a very strong statement. I can also say, for each method, this is the precondition, this is the postcondition. And then you know, okay, that's what my method is supposed to do. Okay? So you see, these are very nice for specification, for testing, formal correctness, and user interface adaptation. So somehow I said object editor makes use of this, and that, struck people's imagination. So what could object editor do with preconditions?
When you hover over something, you could say, hey, this is the things that are allowed in this field.
Okay, so we did see a tooltip use. I don't know if I told you or not, that with the explanation annotation, you could go and say, this is what should happen. And you're saying when you hover over a property.
Or like whenever you have give inputs,
Okay.
you could have a tooltip show up saying what the precondition is.
Okay, so whenever, I always said, I ask these questions not to test you out, but to learn. And I've just learned something. So I could go and hover over a property, and it could say that, look, the precondition of this is height should be less than 0, or height should be greater than 0. Unfortunately, object editor will have to go into your precondition method and figure out and translate somehow that code into a message. And in general, it can't. Okay, because in general, programs can't analyze other programs. I don't know if I mentioned this to you before, but have I ever told you about something a program, the limitations of writing programs that analyze other programs? I know you. So can I write a program, a grading program, okay? So I'm not checking whether you've implemented interfaces, whether you've got the paint method. I just want to test if your program halts. That's all I want to do. Okay? That in the end, it's going to terminate. How hard a problem do you think this is? Sorry. So did somebody say very hard, not hard? Very hard? Impossible. Really? Is it that hard? You think so because you know, because you just feel it's too hard to do? It's impossible. Okay? And you have to take another course to figure out why it's impossible. Okay? So if I can't tell whether the program halts, can I really figure out its precondition? Perhaps not. You know what the message should be. So there's only so much you can reason about a program. Okay? But I could do that. But I can't go and tell you quite the message. But when I'm inputting a property, what else could I do as an object editor? I can't tell you what condition you should, what is the condition of violating it, but can I figure out whether the condition has been violated? I can give a user an error message saying some conditions, but can I know in object editor that the condition is not violated, that the precondition of a particular method is not true? Remember, if we have a convention, if I have a method and a very well-defined method that says that maps the precondition to the method, object editor could call that method to see whether the precondition is true or not. And then I can disable a menu item, I can disable an item, I can remove it from the display. So it can certainly figure out whether the condition is true or not before calling a set or a get. But it can't quite figure out the right message to print out, okay, because the condition itself.
So I think I found it. It's called the halting problem, right?
Yes, that's a very famous problem, and in some courses we tell you how to do things. This is what you do. In some courses we tell you not even to try to do certain things. That's very important. I can't tell you how many times people have tried to solve problems like the halting problem. And think about this. I don't want to go too far away from this. But, today our important problem is to detect something as a virus or not, right? If I can't detect if a program halts, I can't detect if a program does certain thing. I can't even detect whether the program is equal to another program. I cannot theoretically determine whether the program is a virus or not, in general. Yes, I can use some heuristics or hacks, depending on what your viewpoint is, to figure out whether it's a virus or not. I can know that these viruses have this kind of behavior. And of course, we are grading your program, so it's good to have these impossible problems because we can build some approximate solutions. In fact, if there were not these impossible problems, we in academics wouldn't have jobs. Okay, because when you have really hard problems, we know when you have impossible problems, then you can try to say, okay, in this case I can do this, and in this case I can do this, and there are so many cases, so I can get a paper for each case, and I can be a researcher. Okay, so it's good to have sometimes from an academic point of view, but it's also good to know your limits, so that you don't try to go and spend all your time trying to solve the halting problem. Okay, user interface adaptation. Could I go and, given that I know the precondition of get BMI is pre-get BMI, if I follow that convention, could object editor do interesting things? Okay, and with public methods, other classes can discover preconditions and not violate them. So basically, object editor will say, look, its precondition is not true, so I won't even call get BMI. And what can it do? If it's displaying a widget that say displays this value, it can go and gray out the widget. It can not display the widget, and it can do things like that. So basically, if you have a property that is being displayed, then that widget can be disabled or hidden. If you have a menu item that is being used for a write method and its precondition of that method is not true, it can gray out that method. Okay, so I can see in the user interface whether you guys have implemented the preconditions or not by looking at the UI effect. So we'll just see, and so this is the object editor convention. The precondition of method M is pre-M with no argument, and where pre-M returns a Boolean. And M could be a read, write, or some other method. So let's just see, and we can use these preconditions also by test. And let's just see here. So my height and weight were fine. So I saw a BMI value. Now I committed to the 0 value. And at that point, object editor had to go and call get BMI to display the value. And it said, I'm not going to even call get BMI. Okay? I could have graded out, but I want to also have this feature for graphics. So if you have an avatar and its property is no longer true, okay, I can go and make the avatar disappear. In fact, you guys can have characters appear and disappear from the scene by just putting appropriate preconditions. Okay, you don't have to go and remove your setter methods and getter methods and put them back in. But just putting appropriate preconditions, you can have dynamic scenes. Okay, so enter Arthur, enter Lancelot, leave, and somebody goes into the gorge, they can just disappear from the scene by making the precondition of that method false. Okay, so that's what I'm thinking I'm going to put in the assignment that I write on Thursday. Okay?
So if object editor, if you made it an argument object editor, whatever, you're saying that there's a method and there's a pre-method, and then inside the pre-method there is some type of a string or some type of an attribute that you're looking for, then you could also have that print out when the user puts in that.
Oh, so you want the user to be prevented from entering a value too. And I could have a little annotation that says, I could have a little annotation along with the precondition method saying, whenever the precondition is false, say that this is how they can, this is what they can do to make the precondition false, true.
Yeah, so
Okay.
they can have that visual feedback.
Okay. So think of a careful design and let me know. I'll put it in. Okay. So works for graphics and text properties. And here's something else. Notice that I have gone and changed. So there were some initial values of height and weight. And what I did was, and they were given by the constructor, they were decent values. I made weight 0.0, okay, so that made the BMI disappear. And now I want to go and invoke a method in a BMI spreadsheet that says, oh, I did something wrong, please restore that height and weight, okay? And the BMI spreadsheet could be keeping track of these values, and it could go and restore them, okay? So the values are restored. But notice that my restored height and weight no longer is enabled. That makes sense, right? It's not enabled because there's nothing to restore. You are at the initial value. And how did object editor know that should gray it out?
As a precondition, if you have a value to go back to,
So it has, sorry?
as a precondition, if you have something to go back to,
So it meaning what has a precondition? The restore height and weight. The restore height and weight method, which is the one it's displaying in the menu, has a precondition, and object editor just evaluates the precondition and says, oh, you're no longer valid? I'll go and disable it. Okay. So that's what's happening here, that not only am I keeping track of height and weight, I'm also keeping track of initial height and initial weight. Whenever the restore height and weight just does the obvious thing. And the pre one goes and checks if height is not equal to initial height or weight is not equal to initial weight. If either of these two conditions is true, it makes sense to execute restore height and weight. Otherwise, it doesn't even make sense to execute restore height and weight. Okay? So you can create these dynamic user interfaces now. Okay? Questions?
Yeah.
And here, I'm just going and storing. James?
so because object editor sees that pre-restore height and weight is false, and thus doesn't call restore height and weight,
Not only does it not call restore height and weight, it doesn't even allow you to call restore height and weight.
but that's why it doesn't, the program doesn't terminate, because it never actually evaluates that assert statement.
That's why this assert is never exactly very good, because it doesn't call restore height and weight. Assert is never even called, so it won't terminate if assertions are enabled. Just remember that. You're going to say, "Oh, I put this assert in and it doesn't behave as I expect it to," and that's because you didn't enable assertions. Exactly. So we want to prevent rather than cure problems to some degree, and that's what Marcos is very obsessed with. How can I even, make sure that the wrong value is not entered, right? Peter?
So, based on this example, if the initial height and the initial weight, for example, were 5'5", and then you input a new height and weight into the object editor, and then you, for example, that could be like 10'10", and then you enter a third one after that, that could be like 0'0", and you try to restore that, will that go back to the original 5'5"?
It'll go to the original 5'5".
Okay, so it'll always go back to the original.
And actually, based on this example, I thought you were going to say something different. If you put 5, 5 yourself, then you can't do restore height and weight because it's not going to change. If you even manually put 5, 5, the assertion will be false. Okay? Yeah. So this is, how you make a bunch of changes to Word and say, I just want to go back to the initial state. That's what this is. It doesn't let you undo, but undo is something that is a different subject, which we probably won't get time to look at, but maybe might. Okay? But if you're interested, I have got slides on that. Okay? I have taught that stuff in some other versions of this course. Yeah, but there's no incremental undo here. This is just saying in tech. And just one thing that we are not going to test this in your projects, but a class precondition is a precondition that is true for all public methods of the class. Okay? That's just combining all the methods together. A class postcondition is something that's true for all the methods in the class, and a class invariant is invariant of all the. Sorry?
Do you have to include these in the interface as well?
You can't include assertions